Next up is our last speaker of the evening, Kresten Krab from Humio. And he's going to tell us about actually what Paul just talked about as well, Humio, which is a new tool for ingesting a lot of data and doing ad hoc queries.
For me also?
Want the blue box?
Wasn't there a hands-free? Anyway.
There you go.
Okay. Well, thank you very much. So yes, my name is Kresten. I'm CCO in Humio, which is a mostly Danish-based startup. And I'd like to talk about not so much, at least in the beginning, the product itself, but why we're building it. And I'm hoping to bring this whole discussion a little more down to earth, to some real data. So hopefully you will hang around for that. Do you think we can get this hands-free mic working? Because I might be needing both hands at some point. Well, where is it even? Oh, you can work on that. Okay. There's a certain background noise here. Can you hear me?
Yes.
Is this fine? Okay. So just a little bit about me. I'm Dr. Kresten. I spent some years at Next Computer in Silicon Valley. I'm co-founder of Trifork, which is this solutions consulting company. We're about 450 people now. And I've been CTO for that for about 20 years, doing odds and ends and all kinds of firefighting and consulting, internally and externally. I've had quite a lot of activity with Erlang in recent years. I know here at Klarna, at least, there's quite a lot of Erlang going on. I've been hacking Erlang quite extensively the last few years. I built Erlang VM in Java, among other things. So the last year, I've kind of taken a leave of absence from Trifork to do a startup, this Humio thing. And I'm quite excited about that. So why are we doing all this? Really, the thing is, I'd like to bring back this notion that you can feel the hum of your computer. It used to be, this is an old gear computer in my computer science department in Aarhus. You could actually walk into this. You would walk into this to sit in front of the computer to work with it. It was right there in front of you. And when I studied 25 years ago, I would have my next workstation right in front of me. I could feel it, I could hear it, I could interact with it. You could hear the spinning disks. You could hear the interaction between the network card and the sound card. It would go in strange ways. And this hum, this feel, I'm really missing that today, right? Have you ever been on a big ferry or ocean boat and all of a sudden the engine stops? Right? The hum disappears. It's really bad. Something, ooh, that's really uncomfortable. You didn't notice that sound, that dunk, dunk, dunk going on all the time until all of a sudden, oops. It's very, very, very strange and uncomfortable that the motor isn't going. And, today, we might be sitting in our tranquil development environment here at Klarna or somewhere where all the computers are somewhere else and we have no idea. Is the system on fire? Does it operate as normal? We're completely disconnected from this, right? In so many ways. We only realize when the system, everything goes down and, or off, and that's what happens. So what do other kinds of engineering do when you have to have an idea of what's going on when you have something that's far away. You know, with microservices and cloud and everything today, we're moving the computers and the systems away, and we're losing kind of touch. That's kind of the premise, right? In other areas, what you do is, you know, you build an ops center like this, right? Say you're sending Apollo mission out to the moon. You have an ops center, and you have these various displays that give these people a sense of normal. You know, it might not make sense to you and me, and initially it might not even make that much sense to the people sitting there, but you know, if they sit there for a long time and look at this, they get this sense of normal. So if all of a sudden something is different, they'll notice. And that's kind of the same thing that we do with software, right? We build ops centers, put dashboards on the wall. And this is super functional to have some kind of dashboard sitting on the wall. There's lots of software for this, but if you use it, I urge you to actually buy a TV and put it up on the wall, because this simple fact of having it sitting right there means you can just glance up at it, you can look at it anytime. And it might not make that much sense what's on these screens, but what happens is we'll take the machine learning up here in your brain and apply it to what you see. And if something changes, if there's an odd pattern, the motor stops, or maybe something more subtle than that, you'll recognize that. So it's a really inexpensive way to apply AI, or actually it's just to this kind of problem, right? So 10 years ago, so the team behind Humio, actually we all worked on the same project at Trifork 10 years ago, where we built this healthcare infrastructure for the Danish drug administration. And so this is basically all prescriptions and drugs, all the legal drugs in Denmark at least, go through this centralized service. And it's super important to have high availability. There's high security requirements. There's lots of servers and lots of connected systems where things can go wrong. And in doing this, we were introduced, to being careful about our logs and actually monitoring and working with this. And it's super valuable. It's super valuable to have a sense of what's normal. Because assume you have maybe this, today the graph looks like this, you can see prescriptions being issued, there's lunch break for the doctors, they're not prescribing so much drugs in the lunch break. The next day looks like this, everything is going normal, the ship's engine is humming away, and then all of a sudden you see a different pattern. And this kind of was the start of a much more pervasive change in our projects to bring on logs, because this was the foundation. The foundation of all this was just logs, log data. This is you can see, that's the noise that's being emitted from our IT systems. That kind of, it's a signal that we can make some kind of sense out of, is the log files. They're just lying there, and lots of projects are not really using them much. But once you start working with logs and say, what happens if log is a first-class citizen? It has a profound change in your project. And I think this is a kind of thing that you will see over time. It's kind of like when we were first introduced to test-first programming, to continuous integration. You couldn't really see, the value immediately, and it's kind of cumbersome to always, have to set up a CI server before you start a project. But now, when we look at a new project, we care about the logs, and there's lots of interesting interactions happening around this, because once you care about your logs, there'll also be kind of a gardening of the logs. You'll start to look at the logs and say, maybe we can make them better. How can they best provide feedback to how our system works? So this changes a lot of things. And having, of course, the logs in themselves, if they're just sitting down there in some files and all these servers you saw before in the data center, they're not providing much value. So we want to bring them to life and be able to interact with them and extract information out of them. So, there's a lot of things you can do with logs. You can observe and monitor your system, right? Just like the dashboard you saw before. You could take the value out of the logs, bring it up to monitor, see what goes on. And actually, the most simple thing of just put up a dashboard with a graph that shows how many log entries are even happening. It's super, super basic. Don't even try to filter anything, just show how many log entries are aggregate in the system. You know, if that graph suddenly falls, there's something wrong. Or if it suddenly rises, there's something. It doesn't have to be complicated. It doesn't have to be, you know, that you have to extract and describe lots of patterns or schemas for what's really in these logs. Something as simple as just counting log lines as an aggregate number and showing a graph like that is, you know, that's a start. That's a starting point. And it's important to stress this starting point because what's happening as soon as you start caring about your logs, you want to iterate on it. You want to improve how you extract information out of them, and you want to. And this can happen in baby steps. It doesn't have to happen overnight. So I have a long list of things we do. You use it to understand and debug your system. You know, as the systems become more and more distributed, the logs become the reference of what happened in the system. So to understand interactions, when something goes wrong, it's super valuable to be able to grep in them or search the logs. So of course we used to do this when I was sitting on my single next station. I would just tail F a log and see what happened when I changed something. I would grep it to find something. But we kind of lost that ability in this distributed microservices, cloudy world because it's just, you just throw the systems out there and then you kind of hope they're running and maybe you have some various monitoring systems that look at bits and pieces of it. But if you can pull it together, you can actually use tools to provide value across that. You could also use it to feel comfortable with your system, say, in the healthcare project, you know, you'd know that, say at some point we had 10 integrations and we had another batch, another region of Denmark that we were bringing on, their hospital systems. Do we have capacity to that, to do that? And how do you know? Because it's impossible to know by, you know, computing some numbers up front. Architecture and scaling of architecture is always, you know, you have to measure and try to run it. And when you run real systems, you want to know you have capacity, say, to bring on another couple of clients to run the system. So you can use the logs to do that. You don't have to build specific infrastructure to do projections and compute trends. You can just look at your log or your activity levels. So that makes sense, of course, if you also put in your logs, how much free disk space do I have? How much capacity do I have? How does that compare to other trends and number of transactions and whatnot? And it's super valuable when something goes really, really wrong to keep logs for a long time. So you can go back and see. Actually, often logs, because they're text, right? You can go back and look at something you didn't know was interesting. You know, we tried some of these logging mechanisms where you basically extract the data and put it into a database. But then often what happens is, at some point you realize, ooh, I wish I indexed that. I wish I extracted that information out and saved it. And text logs they're super easy to compress. They don't take much space on disk. So keep them around because that makes it easy to try to run post-processing after the fact and compare to, say, what happened last month or last year. You can also easily say, see the events that happen in the log can be used to run tests. So if you have a logging system where you can easily separate streams of logs, say this is my test system, you could have system integration tests that says, when I'm finished running this set of things, I expect that these things are in the log. And that's an easy way to do integration across a range of different services. So it could be different products where you don't control the logs. It could be SQL servers or cloud services or whatnot. As long as you can extract these text logs, it's an easy platform to build these kinds of validations and build that in to your test suites also. Then there's DevOps, and here I put a bar between Dev and Ops. In our healthcare project, we actually had we're trying to run DevOps, but at the same time we had these high security issues because of course we were dealing with healthcare data and people's drugs and all this. You can imagine there's strict security requirements, but actually providing a log is a read-only view into the system. Actually, so what ended up, we ended up getting permission to actually read the logs of the system. But reading the logs with an audit log. So every time we actually go and query the logs of this healthcare system, we have to describe why we do it, and there's an audit log describing who did what at what point. So the logging system ended up being, a view into this completely isolated system where we couldn't affect it. Everything, every deployment, every change had to go through change control and change management, and ticketing systems, etc., etc. But at least we could get this view into the live system when need be. So we also often ended up using the logs to prototype new features or new reports that could be included in the product. Because once you have the logs, all this information there, if you have a flexible, accessible way to extract information out of it, you don't need to build or program a complex system to extract this or put that in production. Just do prototype or ad hoc kinds of technical intelligence. Often there would be some business user calling in saying, are there any cases where doctors do so-and-so in relation to a patient within a given period? You could run these simple transactional loads on the logs to see how often these things happened. So all this information is right at our foot. It's sitting right there. And you don't really have to you don't have to log a lot. You don't have to necessarily change your logs a lot. But basically, in most cases, these logs are just there. They're sitting on these servers, and they are difficult to access, and they're difficult to iterate on. So that's the whole idea in Humio, is to bring that up, make that accessible. And if we look at a little bit on the design space of this, one important thing when you work with this is you want the experience to work with these logs, with this data. So you could say this is data-driven software development, right? Just like we had all these talks, various talks about data-driven or AI-driven businesses, right? This is applying the same thing in our own turf. You want to be able to be interactive. You want to be able to iterate and explore this data. This kind of, I like to think of it like what Excel is to numbers. With Excel, a spreadsheet, you can easily sit and play around, and you can sort different columns, and you can send it to each other and talk about it, and it's right there, flexible, kind of permissive. You want that for your data. You want it to be readily available and interactive. So we always hear, data science is batch and scale and large Hadoop clusters, and there's so much data you can't really do it. You have to program it and then run a batch job, and maybe you get the answer the next day. Or if you're running logs, you want it to be available so you can use it. Another thing is, this is one thing we want, right? The interactiveness. You also want. There's also this kind of tension between historic or live data. You want something where you can access the data as it happens. several of these logging systems use so much CPU power up front to process and save the data that you can query the logs of what happened yesterday or this morning or something like that. So we're actually trying to bring stream processing and in-memory processing, kind of like what you do in high-frequency trading, to log analysis to make this readily available. Of course, if you have larger historic data, you also need to be able to process that. And then finally, I think it's an important learning that it's super valuable to have the flexibility of defining your schema at the point when you read. Of course, as soon as you try to do anything structured with your logs, you need to pull out some information out of it, then some numbers or some names of things or services or names of errors, etc. And at that point, it becomes data. You extract the data. But it's super, super valuable to actually keep the text around so you can extract new value out of it as you go along. So, of course, if you do schema on write, if you do something where you discard the text and you take the important pieces out, that could potentially be much more efficient because you discard information you don't want to save. But in my experience, it often happens that you're in this situation, as I said before, you say, I wish I indexed that. I wish I saved this piece of information because kind of in retrospect, you're in a live system, you can't necessarily afford to rerun some experiment. It already happened. I wish I had that information. And often, this can be the presence of particular strange errors that you didn't think important up front. So actually having the text, the richness of being able to apply the human intelligence to interact with this data is quite important. So that's what we're trying to do. And I'd like to that's what we're trying to do. Allow people to iterate, explore, show data, this kind of liveness and feel of Excel. Just like what Excel is for numbers, we want to be that for log files and for data, for text-based data. So it's kind of a pity not everybody is doing this. Of course, huh? Not everybody's doing this. And it's about time somebody democratize this and make this available and easily accessible. So kind of in a nutshell, Humio tries to be fast, flexible, affordable, simple to use, install kind of thing that you could just throw at your log files and get started. So I'd like to show, I know it's kind of late, but I'd like to show just a bit what it looks like. So here's a screen that shows me just doing a free text search for Klarna. So the data set that I have behind here is I've set up this demo system. You can go check it out yourself at demohumio.com. Is the live logs from GitHub, all the public repos on GitHub. So we're pulling in that live. And so if I just free text search for Klarna over the last week here, I could try to rerun the query. It takes a bit of time. You can see it kind of runs backwards through the GitHub logs, things that happened at GitHub this runs through free text, the entire thing that happened at GitHub the last week. So it's still pretty fast. And what comes out here are these JSON structures that are kind of long, and in this case, it's something that describes a push event. So that means somebody pushed some data to a GitHub repo. So just to avoid the typing here, a next step could be I take all these Klarna logs and then I pipe it into an expression that says group by the type, this is the type of log, and the repository name and sort. And we get something like this. The most interesting thing, or the most active thing, was push events happening on the Klarna/UI repository. So again, that's something you could do in a live system. You can see the meaning of explore and iterate is that you actually get the responses relatively quickly. And there's a simple, so we're just thinking of this as, this is like the Unix command line where you say grep into sort into awk something kind of modern version of that works across a data set. So we have some visualization, so you can, instead of just showing a table, you could do a time chart. So these are the Klarna repositories that where there were commits being pushed to. See, again, the most active one here being Klarna UI repository. I don't know what that is, but it doesn't matter. Somebody who looks at whose data, this is their own data, it makes a lot of sense. So it's kind of, I also experience this when I show this to people. You know, if I show somebody else's data, something they don't understand, it doesn't really make sense. It's kind of like, imagine somebody demoing a spreadsheet to you with numbers or accounts or something that doesn't make sense to you. Then maybe a spreadsheet in Excel isn't that appealing. But if it's your own numbers that you can sort, then all of a sudden it becomes more interesting. So there was recently this huge discussion on Hacker News, right? Which is better? Is it Rust or Go? Right. So I thought for tonight I'd make a little dashboard that shows at least the activity level on GitHub. So you see here, this is the activity the last hour of just kind of all kinds of events. This could be comments or pushes or whatever. Rust was one this last hour. I can tell you earlier today there was more activity on Golang. The overall activity the last week, it was most on Rust. The likes, so that's and on GitHub, you can do these just like kind of Facebook likes. They're called watches, watch events, people watching it. Actually, Go is getting more. And here's some examples showing up the top committers for Go versus Rust. And actually, Rust has a lot more commits. So this Boris guy, I don't know who he is, had 532 commits this week. So we could try to dive into a few of these. The most simple one is this one. So if we look at the query, so here I simply said, I want to look for the repository name is Golang Go, or the repository name Rust Lang Rust. And then I want a time chart where the series is the repository name, and the span of detail, that's the width of these bars, is one day. So that was that. We could make it 1 hour. You can see it hour by hour competition between these two repositories, right? So again, this is actually running over the entire GitHub dataset for a week. So it might look like it's a bit slow, but there's actually quite a lot of data behind it. So let's go back and see this activity. The overall activity of the last hour. This is, you can see in total, we had total of 61 events happening the last hour here. So again, I say repo name is Golang star or Rustlang star. It's just to broaden, it's all the repositories in those spaces. And then I run a regex, I extract this, what this does is it extracts the first part of the repository name, the owner of repository, right? And then I group by that. And you can, because the way the data store is built, and that's the secret sauce in all this, of course, it's a super nice data store for doing this. Both stream processing, as we see here, and MapReduce processing over larger data sets, where you can actually run. So we could try to run this over. So basically, if you say I want a fixed date range here, then I run some MapReduce job over that, or time window, Then it runs a MapReduce job over the historic data and then starts an event processing stream for new incoming events. So we could run this over the last month for all GitHub data. You can see the competition coming along as we go backwards there and count. So here it's actually running this is just running on a single machine. You can see on the order of 5 gigabytes per second processing through the log data, which is like 5x the disk speed. So I guess that was it. Now you have a little idea of what Humio is. There's of course a lot more to it, but maybe there are some questions we can take here. Thank you. Yeah.
Okay, do we have any questions? Up here.
Thanks. I have a question. What's the advantage of Humio compared to if somebody uses Logstash and Kibana, to put like the data Elasticsearch and use Kibana?
Well, we try to make it really simple to operate, right? So it's one thing is it's just a single thing that you can much more easily get it up and running. So operationally, it's a lot simpler. But I think the big thing is that we move the cost of organizing the data from ingest time to when we query the data. So that means you don't need as much disk space. So when you load data into Elastic, generally it bloats a bit. It gets bigger, depending on how much you index. If you just throw JSON at it and say index everything, it could be up to 10x maybe. It also uses a lot of processing power. So it might be that you can easily get in a situation where it's behind. It takes time before you can before the indexes are up to date. So with Humio, we really squeeze the ingest time to a minimum, and these real-time queries, we call them, which are really kind of stream processing queries, they actually attach to the ingest pipeline, so those results are readily available at any time. So we actually apply back pressure through the ingest pipeline to be able to compute those. So again, storage. So the CPU load and the storage load on ingest is a lot smaller. So that also means, so Humio, we actually compress the data. So we often end up with data that's, say, 5 to 10x smaller than the ingested data set. And that again, so if you compare 5 to 10x bigger to 5 to 10x smaller, then we're often in a situation where there's 25 to 50x disk space in an ELK setup. So if that's something that matters, in our system it means we can have this multiplier more of data essentially sitting in the operating system's disk cache. So if the working set of what you're querying, say a day or a week of data, if you compress that 10x and can fit it in working memory of the system, then you actually get these really nice performances of querying it. So, yeah.
I have one more follow-up. So, given that somebody is willing to do the upfront investment in terms of the disk space, and if you forget about the performance, in terms of querying the data, if you can mention the advantages of Humio compared to a system like Kibana, I would appreciate that as well.
In terms of querying the data, one of the goals is to make it really easy to do. We have this query language. If you try to query in Elastic, you have to write these relatively arcane JSON expression, and it gets kind of backwards. So we had focus on the usability of actually make it easy to do and play with. So that's part of the experience, right? And I'm sure you could imagine writing a front end to Elastic that would allow you to do some of these things, right? So in terms of, so if we're not talking performance, so access to it actually, we have, so Humio implements the same ingest APIs as Elastic. So if you have an Elastic setup, you can actually just point it to Humio, and your ingesters will think that it's an Elastic cluster. So it's very easy to try out in parallel.
What AI do you put on top of Humio?
So in Humio itself, we don't have AI.
But you don't have any interface to? So
We have some people doing it, but they select and extract transform data. So there's a JSON API to extract data and then pass it to Python systems that do AI. Yes. Mm-hmm.
I want to bounce a bit on your question. So, so what you have described is that it's a system that is more efficient than, let's say, Elasticsearch plus Kibana, but does it fulfill the same needs, or is
well, Elastic is a great general purpose database that can do all kinds of things. It can do free text search at scale, and you know, it's much more of a database system. It has all kinds of other requirements and properties of a large database system. This is a specific niche tool to process text logs, right? So it's a different. I mean, we have an advantage and we have a much narrower use case.
What
right?
I mean is that from an outsider perspective, it's not very clear if you use Kibana plus Elasticsearch, if it's fulfilling the same needs or the different needs. I don't see the difference, to be honest. As an outsider, it might be much more efficient for large volumes, but that's how you solve the problem.
Right.
My question is, do you solve the same problem?
Well, I think we provide. So what we see is that people want to play with this, right? With Kibana, several of our customers we come into, they've set up Kibana, and they don't go and change it. They don't go and play with it and understand it. But when it's so accessible with this simple pipeline language there, everybody can go and play with it. And you can easily go and change these dashboards yourself. So it's much more of a usability probably experience. It's the flexibility of being able to go back and extract values, apply a regex over old text logs is an issue, or is something that you know makes it the flexibility of that. But just trying to be really friendly to the user, I can say. Yes.
Sorry, I interrupted you maybe. I just wanted to comment on your question, because I have some experience working with Kibana and Elasticsearch, and in the meaning that I really didn't understand how I should do it, because in the systems that we have set up, we have all these, you know, the open source stack of data analytics, right? But they are basically too complicated, so we tend not to use them, and we tend to analyze the logs manually instead, because, you know, how do I set up a data search in Kibana? I just don't get it, and there's no documentation for it, and yeah. Unless you're maybe a fancy data analyst.
Oh, okay. Any more questions?
As you also welcome.
Over here.
There's one more here.
This is our last question.
Yeah.
So given that you postpone a lot of the complexity to the query time, how do you make sure that this actually stays performant if you have like a growing data set of historic data?
So so there is, if you have to run over a large data set, then there is it does take time. So as you saw on a typical single machine setup, maybe we can run right now 5 gigabytes per second, right? So if you have a terabyte of data, it takes a while, right, to run a processing job over that. And That's just how it is, right? Then, if you then set it up as a stream processing query, then it becomes you attach it essentially to the ingest pipeline, and you select and compute those numbers as part of computation. So typically, you would explore and figure out, I'd also like to compute this number, and maybe it takes a little more time. In the beginning, maybe you run it over a shorter time interval, or try it over longer, and then set it up as a live query. And then you basically, it's just a small incremental overhead on the ingest cost. Because it's just sitting there and it's shared across multiple users that, say, put it on the same dashboard. So yes, there is a different trade-off, definitely. And there are definitely workloads that are too big for this to be meaningful. Like, if you have a terabyte data per hour, then you can't really do any meaningful computation back in time, right? Then, yeah. Okay, thank you. You're welcome to come up here and ask me questions also.
Yes. So, I feel kind of stupid talking into the blue box, so I'm going to switch over here. Thank you all very, very much for coming. I hope that you enjoyed the evening and that you're going to join us again in April. Remember to answer our survey for the chance to win a ticket to go to Copenhagen. Thank you.
Hi. I saw you sitting there smiling all the time.